A power strip is a block of electrical sockets that attaches to the end of a flexible cable, allowing multiple electrical devices to be powered from a single electrical socket. Power strips are often used when many electrical devices are in proximity, such as for audio, video, computer systems, appliances, power tools, and lighting. Power strips often include a circuit breaker to interrupt the electric current in case of an overload or a short circuit. Some power strips provide protection against electrical power surges. Typical housing styles may include strip, rack mount, under monitor and direct plug-in. Control. Some power strips include a master switch to turn all devices on and off. This can be used with simple devices, such as lights, but not with most computers, which must use shutdown commands from the software. Computers may have open files, which may be damaged if the power is simply turned off. Some power strips have individually switched outlets. Master-slave strips can detect one master device being turn off and turn everything else on or off accordingly. Remote control strips are used in data centers, to allow computer systems or other devices to be remotely restarted, often over the Internet. Indication: many power strips have a neon or LED indicator light or one per output socket to show when power is on. Better quality surge-protected strips have additional lights to indicate the status of the surge protection system, however these are not always reliable as an indicator. Energy-saving features and standby power. Some power strips have energy-saving features, which switch off the strip if appliances go into standby mode. Using a sensor circuit, they detect if the level of power through the socket is in standby mode, and if so they will turn off that socket. This reduces the consumption of standby power used by computer peripherals and other equipment when not in use, saving money and energy. Some more sophisticated power strips have a master and slave socket arrangement, and when the master socket detects standby mode in the attached appliance's current it turns off the whole strip. However, there can be problems detecting standby power in appliances that use more power in standby mode as they will always appear to the power strip to be switched on. When using a master/slave power strip, one way to avoid such problems is to plug an appliance with a lower standby wattage into the master socket, using it as the master control instead. A different power strip design intended to save energy uses a passive infrared or ultrasonic sound detector to determine if a person is nearby. If the sensors don't detect any motion for a preset period of time, the strip shuts off several outlets, while leaving one outlet on for devices that should not be powered off. These so-called smart power strips are intended to be installed in offices, to shut down equipment when the office is unoccupied. It is recommended that appliances that need a controlled shutdown sequence not be plugged into a slave socket on such a strip as it can damage them if they are switched off incorrectly. Within Europe, power strips with energy-saving features are within the scope of the Low Voltage Directive 2006 EC and the EMC Directive 2004 EC and require a CE mark. Socket arrangement. In some countries where multiple socket types are in use, a single power strip can have two or more kinds of socket. Socket arrangement varies considerably, but for physical access reasons there are rarely more than two rows. In Europe, power strips without surge suppression are normally single row, but models with surge suppression are supplied both in single and double row configurations. If sockets on a power strip are grouped closely together, a cable with a large wall-wart transformer at its end may cover up multiple sockets. Various designs address this problem, some by simply increasing the spacing between outlets. Other designs include receptacles which rotate in their housing, or multiple short receptacle cords feeding from a central hub. A simple DIY method for adapting problematic power strips arrangements to large wall-warts is to use a three-way socket adapter to extend the socket above its neighbors, providing the required clearance. The power cube adapter is arranged as a cube, meaning the adapters do not fight for space next to each other. Surge protection and filtering. Many power strips have built-in surge protectors or MERF5 filters. These are sometimes described as surge suppressors or electrical line conditioners. Some also provide surge suppression for phone lines, TV cable coax, or network cable. Unprotected power strips are often mistakenly called surge suppressors, or surge protectors even though they may have no ability to suppress surges. Surge suppression is usually provided by one or more metal oxide varistors, which are inexpensive two-terminal semiconductors. These act as very high-speed switches, momentarily limiting the peak voltage across their terminals. By design, MOV surge limiters are selected to trigger at a voltage somewhat above the local mains supply voltage, so that they do not clip normal voltage peaks, but clip abnormal high voltages. In the US, this is 120 VAC. It should be borne in mind that this voltage specification is RMS, not peak, and also that it is only a nominal value. Mains electrical power circuits are generally grounded, so there will be a live wire, a neutral wire, and a ground wire. Low-cost power strips often come with only one MOV mounted between the live and neutral wires. More complete power strips will have 3 MOVs, connected between each possible pair of wires. Since MOVs degrade somewhat each time they are triggered, power strips using them have a limited, and unpredictable, protective life. Some power strips have protection status lights which are designed to turn off if protective MOVs connected to the live wire have failed, but such simple circuits cannot detect all failure modes. The surge-induced triggering of MOVs can cause damage to an upstream device, such as an uninterruptible power supply, which typically sees an overload condition while the surge is being suppressed. Therefore, it is recommended not to connect a surge-protected power strip to a UPS, but instead to rely solely on surge protection provided by the UPS itself. More elaborate power strips may use inductor-capacitor networks to achieve a similar effect of protecting equipment from high-voltage spikes on the mains circuit. These more expensive arrangements are much less prone to silent degradation than MOVs, and often have monitoring lights that indicate whether the protective circuitry is still connected. Within the EU, power strips with surge suppression circuits can demonstrate compliance with the Low Voltage Directive 2006 EC by complying with the requirements of EN 61643-11 2002 plus A1. The standard covers both the performance of the surge suppression circuit and their safety. Likewise, power strips with telecom surge suppression circuits can demonstrate compliance with the LVD by complying with the requirements of EN 61643-21 2001. Daisy chaining and surge protection equals. Connecting MOV-protected power strips in a daisy chain does not necessarily increase the protection they provide. Connecting them in this manner effectively connects their surge protection components in parallel, in theory spreading any potential surge across each surge protector. However, due to manufacturing variations between the MOVs, the surge energy will not be spread evenly, and will typically go through the one that triggers first. Daisy chaining of power strips, whether surge protected or not, is specifically against most codes. As an example, the International Code Council's International Fire Code 2009 edition in April 2, 605 states, relocatable power taps shall be directly connected to permanently installed receptacles. Overload protection protects the cable from excess current and override of power. The protective device will automatically switch off when the device is plugged into it, drawing more power than the strip is rated to supply. For example, the standard rating for overload-protected power strips is 2400 W in Australia, so exceeding that amount of power will make the circuit breaker trip. Power strips offering only overload protection generally do not have a power light, but they do have a reset switch, which is used to return the strip to service after an overload has caused it to trip. Safety. Electrical overloading can be a problem with any sort of power distribution adapter. This is especially likely if multiple high-power appliances are used, such as those with heating elements, like room heaters or electric frying pans. Power strips may have a circuit breaker integrated to prevent overload. In the UK, power strips are required to be protected by the fuse in the BS1363 plug. Some also feature a 13A BS1362 fuse in the socket end. Power strips are generally considered a safer alternative to double adapters, two-way plugs, three-way plugs, or cube taps, which plug directly into the socket with no lead for multiple appliances. These low-cost adapters are generally not fused. Therefore, in many cases the only protection against overload is the branch circuit fuse, which may well have a rating higher than the adapter. The weight of the plugs pulling on the adapter can also be an issue if adapters are stacked or if they are used with brick-style power supplies. Such adapters, while still available, have largely fallen out of use in some countries. When plugging a device into a power strip, a buildup of carbon or dust can cause sparking to occur. This generally doesn't pose much of a risk in a non-explosive atmosphere, but it can bother some people. Explosive atmospheres require specialized explosion-proof sealed electrical equipment. U.S. regulations equals. Underwriters Laboratories Standard 1363 contains requirements for relocatable power taps. Included in the scope section of the standard is the statement. 1.1 These requirements cover cord-connected, relocatable power taps rated 250 VAC or less and 20 AAC or less. A relocatable power tap is intended only for indoor use as a temporary extension of a grounding alternating current branch circuit for general use. National Electrical Code recognizes power strip as multi-outlet assembly in Article 380. EU and UK regulations equals. In Europe, plugs and sockets without additional control or surge protection circuits are outside the scope of the Low Voltage Directive 2006 EC and controlled by national regulations, and therefore must not be CE marked. In the UK, the legal requirements for plugs and sockets are listed in Statutory Instrument 1994 No. 1768, the plugs and sockets etc. Regulations 1994. 1. This regulation lists the requirements for all domestic plugs and sockets, including socket outlet units. C. 2. Electrical equipment, requirements for plugs and sockets etc. Guidance notes on the UK plugs and sockets etc. Regulations 1994. The regulation requires all socket outlet units to comply with the requirements of BS 1363-2 specification for 13A switched and unswitched socket outlets and with the requirements of BS 5733 specification for general requirements for electrical accessories. Sockets and socket outlets do not require independent approval under the regulations. Any plug fitted to the socket outlet unit must comply with the requirements of BS 1363-1 specification for rewirable and non-rewirable 13A fuse plugs. Plugs must also be independently approved and marked in accordance with the requirements of the regulation. If a socket outlet unit contains additional control circuits or surge protection circuits, they will fall within the scope of the Low Voltage Directive 2006 EC and must be CE marked. Socket outlet units with control circuits also fall within the scope of the EMC Directive 2004 EC. History. The Electrical Power Board was invented in 1972 by Australian electrical engineer Peter Talbot working under Frank Bannigan, managing director of Australian company Cambrook. The product was hugely successful, however, it was not patented and market share was eventually lost to other manufacturers. See also. Power cord, AC power plugs and sockets, standby power, power distribution unit, remote power boot switch. References. External links, complete disassembly of an older style power strip.